basically there are two types of cryptography. One is symmetric key cryptography and second one is asymmetric key cryptography. In this video we are going to discuss symmetric key cryptography. Now symmetric cipher model, or we can say symmetric key cryptography, consists of different 5 elements. One is plaintext, second one is encryption algorithm, third one is secret key, fourth one is ciphertext, fifth one is decryption algorithm. So if you want to generate, or we can say if you want to perform symmetric key cryptography model, so you must have to use these 5 elements. So this figure shows the symmetric key cryptography. It is the very basic figure of symmetric key cryptography model. In this model you can see over here there is the left hand side, plaintext is the input, so this is the sender, and this is plaintext is output, so this is the receiver. Now discuss one by one these all elements. First one, plaintext is the original message or data that is fed into the algorithm as input. If sender wants to send data to the receiver, so sender have original message or plaintext. If you want to communicate with receiver, so at that time you have to send data with the help of any kind of security algorithm. If your data is secure, so attacker or hacker cannot recognize your original plaintext message. So plaintext message is an original message. Next, encryption algorithm. It performs various substitutions and transformation on the plaintext. So encryption algorithm, so use of encryption algorithm is convert plaintext into unreadable format, or we can say plaintext convert into ciphertext. Third one, secret key. So it is the value independent of the plaintext and of the algorithm. The exact substitution and transformations performed by the algorithm depends on the key. So now we can say encryption algorithm input is one is the plaintext. Here you can see over here in this figure this is X, and second input is the secret key, it is K. So this is secret key, so this secret key shared with only sender and receiver, so no other person known in the network. If any person access the key, then that person, or we can say he or she, can decrypt the ciphertext into plaintext. Fourth one, ciphertext. Ciphertext is the unreadable message produced as output. It depends on the plaintext and secret key. So input of the encryption algorithm is plaintext and secret key, and output of this encryption algorithm is ciphertext. Whenever ciphertext is generated, then ciphertext is transmitted to the receiver side through the secure channel, or we can say through the secure medium. Next one, decryption algorithm. It takes the ciphertext and the secret key and produce the original plaintext. Now right hand side of this figure, decryption algorithm, the input of the decryption algorithm is transmitted ciphertext and input same key which is used by sender. So both are the input, so ciphertext and key. So now output is the receiver side is plaintext. Now you can see over here this is the plaintext is the output, same message as sent by sender. Same key is used for encryption and decryption process, so it is called symmetric cipher. In this figure you can see over here in encryption algorithm key capital K is used, and same over here in decryption algorithm capital K key is used. So in symmetric cipher you can say for encryption and decryption same key will be used. So key is the most important thing in symmetric cipher. If key is lost, then message will be decrypted. So how can we represent mathematically? Now see that this is X, X is the plaintext as per the below figure. Now you can see over here this is the X and X is the plaintext. The E is equal to encryption algorithm. Now see over here X is the plaintext as shown in figure, E is the encryption algorithm is used, and the another input of the encryption algorithm is secret shared key. So now E of Kx, so encryption algorithm input K and X both are applied on encryption algorithm and it generates Y. Y is equal to ciphertext. Now you can see over X is the input, capital K is the input, and output transmitted ciphertext is Y, and Y is transmitted to the receiver side. Now same as decryption process, so Y is the input, so ciphertext and same key which is used by sender. So Y and capital K. Now you can see over here capital K and Y. So this is decryption algorithm used for K and Y. So D of KY, and it generates plain text capital X. So D is the decryption algorithm. For example, symmetric key cryptography algorithm is most popular is DES, we can say data encryption standard, AES, advanced encryption standard, and blowfish algorithm. Here the possibility is that if an attacker got ciphertext, so he or she may apply different permutation and combination to decrypt and obtain the original plaintext. If attacker gets the key and ciphertext so easily decrypted by the attacker, or we can say hacker. If key is not available at the attacker, so attacker will use permutation and combination method and try to decrypt the data and get plaintext. So always sender has to think on applying different encoding technique on plaintext and convert it into ciphertext. Therefore, attacker cannot read the actual message. So we can say permutation and combination of both the sides are different. So attacker will not decrypt any kind of data during the transmission. Advantage and disadvantage. Symmetric key is faster than asymmetric key cryptography. Same key is used for encryption and decryption. Receiver cannot decrypt data without key. So why it is advantage? Because without sender permission, receiver cannot decrypt the data. If key is not shared with receiver, so receiver cannot decrypt data. Symmetric key achieves the authentication principle because it checks receiver's identity. So it based on authentication definition. System resources are less utilized in this cryptography in compare to asymmetric key cryptography. So what are the disadvantages? First one is once key is stolen, while transmitted data can easily decrypt. So we have already discussed before. Second one, in symmetric key cryptography, one is symmetric key cryptography and second one is asymmetric key cryptography. Today we are going to discuss in this video asymmetric key cryptography. Asymmetric key cryptography is also called a public key cryptography, and symmetric key cryptography is called secret key cryptography. So there are 6 elements are there in asymmetric cipher model, or we can see asymmetric key cryptography. First one is plaintext, encryption algorithm, private key and public key. This is the key pairs. Fifth one is ciphertext, and next is decryption algorithm. So these are the essential ingredients of the asymmetric cipher model, and all the definitions of these elements are already discussed in basic terminology of the network security video. First one, plaintext is the original message or data that is fed into the algorithm as input. So original message which is sender wants to send to receiver, that message is known as plaintext. Second one is encryption algorithm. So it performs various transformation on the plaintext. So encryption algorithm is one kind of technique in which input is plaintext and key, either it is public key or private key. So output of this algorithm is ciphertext. Public and private keys. This is a pair of keys that have been selected so that if one is used for encryption and the other is used for decryption. Either public key is used for encryption, so private key is used for decryption. Either private key is used for encryption and then public key is used for decryption. Both the scenario we will discuss in this video. Ciphertext. Ciphertext is the unreadable message. It is the produced by encryption algorithm. We have already discussed about that. Decryption algorithm. It takes the ciphertext and the key as an input and produce the original plaintext. So encryption algorithm will be executed at the sender side and decryption algorithm will be executed at the receiver side. So here key will be either public key or private key in decryption. Also in encryption, either it will be public key or private key. Next, public key is distributed to all the users and private key is known to particular users only. If there are 3 users in the networks, so all the users know all users public key, but private key is known by itself that user only. There are 2 different scenarios of encryption model. First one is public key used for encryption and private key used for decryption. The second scenario, private key used for encryption and public key used for decryption. Now let us discuss one by one both the scenario. First one, scenario 1, encryption with public key. Now this is the asymmetric cipher model in which encryption with public key. Here Bob is the sender and Alice is the receiver. So there are two users in the network. So if Bob want to send the message to Alice, so this is sender, and Bob must have to use public key of Alice because Alice public key is known by Bob. So now you can see over here in encryption algorithm, so input is plaintext and Alice public key. Now you can see over here PU is known as public key and A denoted Alice public key. So input of the encryption algorithm is Alice public key and plaintext which is original message. Message to be transmitted after encryption of message using Alice public key. Output of the encryption algorithm is Y, and Y it is called ciphertext. So ciphertext is transmitted to the receiver side. Alice has received message and she can decrypt the message using only her private key. Now you can see over here, this is the PRA notation. PR is private key and A is Alice private key. So decryption algorithm input is ciphertext which is transmitted by Bob, and another input is private key of Alice, and it generates plaintext output. So this is the encryption with public key. Mathematically this scenario represented as public key of A, now PU of A, and the another input is original plaintext X, and it is encrypted by encryption algorithm, and it generates Y ciphertext. In decryption process, D is the decryption algorithm. In a decryption process, one input is Y, this is ciphertext transmitted by Bob, and another input is private key of Alice, so PR of A. So this is the decryption process and it generates original plaintext X. Now you can see over PUA is equal to Alice public key and PRA is equal to Alice private key. Second scenario. In second scenario, encryption with private key. In this figure you can see over here, this is Bob is the sender and Alice is the receiver. Here if Bob wants to send the message to Alice, now you can see over here, and Bob must have to use his own private key. Now this is the Bob's private key, so we have right over here PR of B. So encryption algorithm input is capital X and PR of B, private key of Bob. Message to be transmitted after encryption of message using Bob's public key. So output of this encryption algorithm is capital Y, and Y is transmitted to the receiver side through a secure channel. Next one, Alice has received the message. Now you can see over here, so Y is reached at Alice side, so we can say at receiver side. So she can decrypt the message using Bob's public key, because Bob's public key is known by Alice. So here you can see over here, so decryption algorithm PUB comma Y decryption algorithm is used. So input of the decryption algorithm is public key of Bob, so it is PU of B, and another input is Y ciphertext, so its output is original plaintext. Now mathematically it is represented. Now you can see over here, this is the encryption process. It uses private key of Bob, so it is PR of B, and another input is X. It generates ciphertext Y. At decryption side, public key of B and ciphertext Y is the input of the decryption algorithm. It generates capital X, so it is the original plaintext message, where PRB is equal to Bob's private key and PUB is equal to Bob's public key. Now pair of private and public keys. So who will know the whose private key and whose public key? Now this is the key detail. See one by one. Bob's private key, so it is denoted by PR of B. So Bob must know, but Alice does not know about Bob's private key. Next one, Bob public key, so it is PU of B. So public key is known by Alice also, so this is Bob must know, and it is also known by Alice. So this is public key, so Bob and Alice both are known. Same as Alice private key. So Bob not known and Alice must know. So this is private key which is not shared with Bob. Alice public key, PU of A. So this is public key. So both user know the public key. It is known to Bob and Alice must know. For example, a famous example of asymmetric key cryptography is RSA algorithm, Rivesh, Samir and Adderman, and Diffie-Hellman key exchange algorithm. These are the famous algorithm of the asymmetric key cryptography. Now, advantage and disadvantage of asymmetric key cryptography. First one, if data is transmitting on insecure channel but key cannot distributing among the sender and receiver, if a hacker or attacker will get the message or capture the message from the insecure channel but they cannot decrypt the message. Separate key is used for encryption and decryption. Even if encrypted message is stolen by attacker or he or she cannot decrypt the message easily. Easy to user for user. Disadvantage, asymmetric key use more resource in compared to symmetric key cryptography. More mathematical calculation required. So this is the biggest disadvantage of the asymmetric key cryptography.